Hey guys, today I'm gonna discuss what are elementary particles and what do we even mean by the standard model of particle physics. My name is Saptarshi and you are watching Cosmos Unveiled. So, we all know that matter is composed of molecules which can be further divided into atoms. Atoms again can be further divided into neutrons, protons and electrons. But are they elementary particles? Well, no. Electron is an elementary particle, but proton and neutron are not. They can be further divided into even smaller particles called quarks. So now the question might arise that are electrons and quarks the only elementary particles present in the universe? Well, again, the answer is no. That is where the standard model comes into action. Now question might arise, what is the standard model thing? Well, standard model is a well-established theory of particle physics which explains three of the four fundamental forces of nature, namely the electromagnetic force, the weak nuclear force and the strong nuclear force. It unfortunately doesn't explain the gravitational force. It is basically an arrangement of all the known elementary particles and mediated particles present in the universe. So let's take a look at it. Here it is. Here you can see that there are so many particles. So let's classify them. There are mainly two types of particles. The fermions, here they are. This group is called fermions and these are bosons. Fermions are particles with half integral spin and they make up matter. Here you can see there is spin half, again spin half, 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 and so many half. The bosons are particles with integral spin and mediate scalar or vector fields. For example, the gluon is a boson, it has a spin of 1 and it mediates the strong nuclear force field. Again, photon is also a boson and it mediates the electromagnetic field. It has a spin of 1. Again, the W and the Z bosons have a spin of 1 each. They mediate the weak nuclear force field. But the Higgs boson here has a spin of 0 and it mediates a scalar field. Let's discuss what are fermions. As I said earlier, they have half integral spin and make up matter. Fermions can be further classified into two types of particles, the quarks and the leptons. The basic difference between quarks and leptons is quarks interact through all the four forces, but the leptons do not interact through the strong nuclear force. There are three generations of quarks and a total of 6 quarks, namely up, down, charm strange, top and bottom. As it turns out, only up and down quarks are stable and form daily matter. The other 4 quarks are very unstable and decay down to up and down quarks. The quarks in the upper row have a charge of positive 2/3 and the quarks in the lower row have a charge of negative 1/3. A proton is basically 2 up quarks and a down quark. The total charge of proton is therefore 1 and the neutron is 2 down quarks and an up quark, giving it a total charge of 0. So now let's discuss leptons. Leptons can be further classified into two types of particles, the charged leptons and the uncharged ones, also called neutrinos. Charged ones contain the electron, the muon and the tau particle, and each of them have a neutrino associated with them. You can also classify leptons into 3 generations, 1, 2, 3. Of the charged leptons, only the electron is stable, while the muon and the tau particle are very unstable and decay down to electron. As we can see here, only the first generation of fermions are stable, while the other two are very unstable. Well, why is that? Scientists are still trying to find an answer to this question. Again, another question comes into mind. Why are there only 3 generations of fermions? Scientists are still trying to find an answer to that question also. Another thing which is quite interesting that every fermion has its own antiparticle, which is the same particle with the same mass but oppositely charged. For example, the antiparticle counterpart of electron is known as positron. Now let's come to bosons. Bosons, as I said earlier, are mediator particles. That means they mediate scalar or vector fields and they have integral spin. Bosons again can be divided into two types, the gauge bosons or the vector bosons and the scalar bosons. The vector bosons are also known as force carriers as they mediate force fields, which are vector fields. They include the gluon particle, the photon, the Z boson and the W boson. As I said earlier, the gluon mediates the strong nuclear force field, the photon the electromagnetic force field, and the W and Z bosons mediate the weak nuclear force field. The scalar boson contains the Higgs boson, which provides mass to every particle. And it is the most recently discovered particle. So that's all for today. See you in my next video.